Today we're going to start with a review of some Algebra 1 properties, and these are properties that pertain to real numbers. Again, A, B, and C, all the numbers represented in this list of properties, they're all real numbers. You may need to refresh your memory that real numbers include irrational numbers, rational numbers, integers, counting numbers, and whole numbers. Alright, our first property is the reflexive property, which says that A is equal to A. Now, anything is equivalent to itself. That's a very obvious statement, but without it, the whole system of mathematics would not work. So anything is the same as itself. That's the reflexive property. We just need to learn its name. Symmetric property says that if A is equal to B, then B is equal to A. So in other words, if we have an equation, we can switch sides, that what was on the left side of the equal sign can now be on the right side, what was on the right side can now be on the left side. That's called the symmetric property of equality. So it doesn't matter, we can switch what's on both sides of the equations. Transitive property of equality starts out by saying if A is equal to B, and we know that also B is equal to C, therefore we know that A has to be equal to C. If a first thing is equal to a second thing, and a second thing is equal to a third thing, therefore the first and the third things have to be equal to each other. Addition property of equality says if we start out with an equation, A is equal to B, we can add the same thing to both sides of the equation, and the equation will still be equivalent. It'll still be equal. The multiplication property of equality is a slight variation on that. We start out with an equation where the left side is equal to the right side, and we can multiply both sides of the equation by the same number, and the resulting equation is still equal or equivalent. So let's try to put some of that into practice. Let's take a look at some properties of equality. We've got the list up here. For example, 1a, we say y plus 7 is equal to 10. What's the reason we can say 2 times y plus 7 is equal to 20, which by the way is 2 times 10. If you look at that for a moment, look at this list of properties of equality, you'll notice, yes, all we did is multiply both sides of the equal sign by 2, so that's the multiplication property of equality. Let's look at example 1b. If x is equal to y plus 3, and we know that y plus 3 is equal to 5, therefore then that x is equal to 5. A first thing is equal to a second thing. A second thing is equal to a third thing. Therefore, the first and the third items are the same. Yes, from our list, that's the transitive property of equality. Alright, and then example 1c, if A is the same as B plus C, therefore then B plus C must be the same as A. If you look to see what we did here, all we did is take what was on the left side of the equal sign, put it on the right. Take what was on the right side of the equal sign, put it on the left. So therefore, that's the symmetric property of equality. Alright, let's look at a few more properties for real numbers. We have something called the closure property. What the closure property says, and that, by the way, we're going to focus on for addition and multiplication. It says if A and B and C are real numbers, when we add two real numbers, the end result is also a real number. When we multiply any two real numbers, the end result is also a real number. We've got lots of properties to cover today, so moving on to the next is the commutative property, which says that A plus B is the same as B plus A for addition, and for multiplication, A times B is the same as B times A. Sometimes students get this confused with other properties, but let me rephrase this. When you're adding, it does not matter the order you're adding the numbers. 2 plus 3 was 5, and that's the same as 3 plus 2, which is also 5. The order we do when we add two numbers is not important. Commutative property also says the same thing for multiplication. 2 times 3 is the same thing as 3 times 2, which we get 6. Notice we are not saying anywhere that this is true for subtraction or division, because it's not. Alright, a way that you can hopefully remember this is the name commutative. I'm going to play on words here. We live in Los Angeles, so many of your parents commute to work, which means they go from point A to point B in the morning, and then when they come home, and whenever they come home, it's from point B back to point A. Alright, associative property. Again, for addition and multiplication, not for division or subtraction. If we are adding three numbers, we cannot add all three instantaneously. We can only add two at a time. Associative property says it doesn't matter if we add the first two first, and then take that sum and add it to the third number, or if we add the last two first, and then take that sum and add it to the first number. Likewise, for multiplication, excuse me, it doesn't matter if we multiply the first two first, and then take that product times the third one, or if we multiply the second and third first, and then multiply that product times the first one. Now again, a silly little way to try to remember associative property is you think of who you associate with. And if you think back on your friendships in elementary and maybe middle school, there might be three of you that are friends, and two of you might start out being closer friends, and the third person's maybe kind of a little bit more distant. Inevitably, there's some kind of conflict along the way, and the other two get to be closer friends, and the first is a little more distant. So it's who you're associating with. That's my silly way to help you remember the associative property. We've got the two identity properties for real numbers, and if you add anything to 0, 0 does not change your original quantity. So a plus 0 is a, 0 plus a is a. Doesn't matter the order we add, that's the commutative, but adding 0 does not change your original number. For multiplication, 0 is not the identity, it is 1. So 1 times anything does not change that number, or anything times 1 does not change that number. So again, it doesn't matter the order we multiply the 1 times the a. 1 times anything is that original anything. This will be important as we go later through the year. If you remember, when you have fractions, you're trying to get a common denominator. You need to multiply that original fraction by 1, but you get a different looking fraction, but it still has the same value. So if you remember that from days past, that will be useful for us this year when we're dealing with fractions that are algebraic in nature or have radicals in them. More on that much later in the year. We have our inverse properties. Inverse properties. The inverse of addition is subtraction, and we sometimes call this the property of the opposites. If you take a and add its opposite to it, you get 0. If you take a and add its opposite to it, and again the order doesn't matter, you still get 0. So 5, its opposite would be negative 5. 5 plus negative 5 is 0. Negative 5 plus 5 is 0. For multiplication, it's a reciprocal. So a times its reciprocal, which is 1 over a, gives us 1. And 1 over a times a also gives us 1. So here we have the additive identity and the multiplicative identity. Adding opposites gives us 0. Multiplying reciprocals gives us 1. The distributive property. And its official name is distributive property of multiplication over addition. So a is being multiplied by the sum of b plus c. And we all remember this from Algebra 1. You take a and multiply it times b, and then you add the product of a times c. Doesn't matter if the a is in front of the parentheses or behind it here. So b times a is ba, plus c times a is ca. The distributive property. My silly way to help you remember that is if you have a brother or sister and mom or dad comes home and gives $10 to one of them, but not to you, you complain and go, wait a minute, distribute the wealth. Gave them 10, give me 10. So my silly way for remembering the distributive property. All right, it's time to put some of these properties to use. Now, I know you can just add these numbers from left to right in your head, but we're going to try to do that using some properties in this situation. So there's our numbers, and I'm going to take these two, 11 and 13, and change their order. So I'm going to group them by putting parentheses around them. Now I can say, well, 7 plus 13, well, that's 20. 11 plus 19 is 30. 20 plus 30 is 50. I know you can probably add that just as easily from left to right. But to illustrate some of the properties, we change the order of addition, so that's commutative. We put some parentheses around here to group them, that's associative. And then we added our results, and 20 plus 30 is 50. All right, example 2b, 26 plus 8y plus 14. Well, let's change the order of the 8y plus the 14. Changing the order of addition is commutative property. We did that because 26 and 14 are called like terms from Algebra 1, which means I can combine them. Putting parentheses around them is the associative property. 26 plus 14 is 40, and 8y contains a variable. Those are not like terms, so you'll remember from Algebra 1, that's as far as we can simplify example 2b. All right, let's take a look at example 3. We're multiplying 16 times the monomial 4xy squared times the monomial 5z cubed. Now let's rearrange this. 4 times 5, let's bring those together, changing the order. And then again for multiplication, that's commutative. Putting parentheses around them is associative. And then x times y squared times z cubed. 4 times 5 is 20. 16 times 20 is 320 of those x, y squared, z cubed. So 320 x, y squared, z cubed is my answer for that particular example. All right, let's go through and see if we can name all the steps involved in this particular process. We're going to simplify. So we're going to start out with 1/3 distributed to 1 plus 3t. And as we go through, our first step is to take that 1/3 times 1, 1/3 times the 3t, and add those results together. Think about it for a second. Yes, the 1/3 is being distributed to both terms, so that's the distributive property. All right, then what we want to do is to take this 1/3 times the 3, put parentheses around them to multiply them. Grouping them by the parentheses then is the associative property, and it's multiplication here. So associative property of multiplication. 1/3 times 3 is 1. What's the property behind that? Property of reciprocals. All right, 1/3 times 1 is 1/3. And likewise, 1 times t is t. Property behind that is the identity property for multiplication. And in step 5, these 3 dots, if you remember your math shorthand, is therefore 1/3 distributed to 1 plus 3t is the same as 1/3 plus t. Now, let's look. A first thing equals a second thing. The second thing equals the third thing. Therefore, the first quantity is equal to the third quantity. Yes, that is the transitive property of equality. All right, and that's our look today in Chapter 1, Section 3 of Algebra 2 at properties.